In this video, let's talk about a LeetCode problem called word search. So let's look at the question first. So we are given a grid which has m rows and n columns, and each cell in the grid has a character in it, and at the same time we are also given a word, and we need to find out whether this word can be composed from the characters in the grid, and the condition being that the characters in the word have to appear sequentially in the grid, and the characters should be adjacent to each other. The direction can be either horizontal or the direction can be vertical, but the characters have to appear sequentially and they have to be adjacent, and there should not be any gap between the characters. So one example of search word is ABC, then C, E and D. So we are going in horizontal direction first, then we are going vertically down, and then we are going horizontally left. Another word, so A, B, C, C, E, D is one word which can be formed. These are just examples. You can have many other examples. So one more word which we can look at as an example is C, C, E, then E, S, E, then maybe S, E, E. So all these words satisfy the condition that the characters in them are present sequentially and adjacent to each other. So CCE is like this, and ESE is like this, and SEE is like this. And let's look at, so this can be formed, this can be formed. Let's look at a word which cannot be formed. So for example, SFA. So if you looked at the grid, so SF although is present, but then A is not available sequential to F, either in horizontal direction or in a vertical direction. So we cannot form SFA. Now let's look at a possible solution of this problem. Okay, let's look at the solution of this problem now. So let me just reiterate that we have a grid of characters, and then we will be given a word which we have to find out whether it is located, whether it can be located within this grid, and the condition being that the characters in the word have to appear sequentially in the grid and adjacent to each other, and they can be either reached by traversing horizontally or vertically. So for example, let's take this word FDE. So let's try to see if we can create a plan for looking up this word FDE within the grid. So we will start our process by iterating the cells in this grid in the direction from left to right. So first we will look at A, then we will look at B, C, E, S, F, C, S, and so on. And for each character that we visit, we will start a discovery process, and that discovery process will lead us to a possible solution if it exists. Otherwise it will tell us that this word cannot be found in the grid. So what we'll do is first we know that we want to look at the first index, which is first index of the word we are looking for, which is F. So we will start from A, and we'll initiate our discovery process where we'll compare the cell character with the character in the word at the location where we are interested currently, which is like the first location as of now. So let me just put in the locations also, 1, 2 and 3, and currently we are at first location, first index. So A, does it match with F? No. B, does it match with F? No. So we keep on traversing from left to right, CE, then we compare S, then we come to this cell and we see that F matches F. So now we can, there is a scope to continue the discovery process. And in order to continue the discovery process, we can define a direction. So for our example, we'll take a direction of right, then down, then left, then up. So basically we are following a clockwise process. So we are at F. Now we want to continue our discovery. So we will in order to see whether a word can be found or not. So we have found the word at the character at the first location. So now we shift our current location to second index, and which means that now we want to see whether a D can be discovered from F. So, and in order to do that, we'll follow the direction RDLU. So from F we will go to C, and again we will repeat the same process. We will compare C with D, and we see that it doesn't match, so we backtrack from C to F and then continue our discovery process. So our the right direction didn't match, so we will now go to down direction, which means that from F we will come to D, and now we'll compare D with this current character, which is D, and we see that there is a match. So now we are okay with the first character matching and the second character matching, and now we have to continue our discovery process. So now from D we'll again follow the same process, which means that first we will visit right direction and we'll go to this cell where a E is placed, and also we know that now we are looking for the third character, which is E. So now we compare this E with this E, and we see that there is a match, and at the same time we see that we have located all the three characters that we were interested in, F, D and E, following the constraint that we have to follow a horizontal direction or a vertical direction, and that the characters which we are looking at are adjacent and sequential to each other. So we see that these all conditions have been met, and then we say that we have finally found out F, D, E in the grid. So now let me just put down this process that we have just now discussed in words. So what we do is, for each character in the grid, we start a discovery process. Okay, so we saw what a discovery process is, and we are going to write it down as well. So discovery. Now let's look at the discovery process, which is nothing but first we so there are a couple of cases within our discovery process, but basically the idea is that match the incoming character with the current character location in the word. So incoming character will be the ones which we are visiting, like this F, C, D, and the current char location is nothing but the locations where we are at, like it could be 3, it could be second, it could be first, depending on the length of the word. So this is the discovery process, which is the matching process. So here we have cases like so we will either have a no match, which means that for example C didn't match with D here. So that was the case of no match. So here what we do is we simply return. Now if there was a match, okay, so it is possible that this was the last character to be matched, which means that you have looked at all the characters, all of them matched, and this was the last character. I mean, this incoming character was the last character, which means that the word has been found, and you return a true in this case. Otherwise, you start your navigation, which means if this was not the last character, then you start looking in this direction R. If otherwise, you look at your down direction. If it doesn't match, then you look at L direction. Otherwise, you look at up direction. Now, the point is that whenever you are going in any of these directions, R, D, L, or U, you have to make sure that you can actually go in that direction. So what I mean by that is, suppose you are at S. So now you want to go, for example, from further do the discovery process from here. So you want to go right, but you cannot go right, because the grid doesn't have those entries. The boundary is S. So you cannot go. So you have to check before going to any direction. You have to check whether you can go to that direction or not. So you cannot go to right. Okay, so you start navigating in down direction. If you are at E, now you cannot go to right direction, down direction, so you can go to left direction. So that is the checks which you have to perform. Other important thing is that, for example, if this right direction navigation returned a true value, which means that the word was somewhere found, then you don't need to look at down, left and upwards direction. Only if this returned false, if this discovery process returned a false, then you need to discover the other directions. That is another thing. And now the question will be like, how do I do the discovery process if I want to go in this right direction? So it is simply a repetition of what you have already done. So the next character, which means the character next to this incoming character which is in right direction. For example, if you are at F cell and you want to go to C cell, so you have to go to right direction. So you will simply repeat this process again, and this is what your recursion is, which means that you have to follow the same steps again. You have to repeat the procedure or the method or the routine again with new set of parameters. So in this case, you will have a new character to be matched, and you will have a new location in the word which you want to match, which means that once you have matched F, okay, so now you want to match the second location, and the new character will be C. So you want to match C with D. So you have a new character C and you have a new location D, and so on. So you have to keep on repeating this process till you reach your case where you reach this condition, that last char to be matched, and you return a true. Otherwise you exhaust all your possibilities and finally you return a false. So this is like the entire process which has to be followed, and if this is converted into a code form, it will give you the solution. But one important thing which we also need to take care of is this case. So you have this grid. I'll just create it again. So now one condition or thing which you have to take care of is that while traversing and while doing the discovery process, if you are at this location, for example, so now it is possible that you traverse from here to here, and then you traverse from here to here, and you traverse from here to here, and then you again have a risk of entering this location which you already have visited. So now if you enter into this loop, you can go in this place forever and you'll not be able to come out, and you'll not be able to search your word. So in order to prevent this situation from occurring, what you will do is you will create a new grid, just to store two values in each cell, which is either 0 or 1. Okay, so your cells can hold either 0 or 1, and the point is that when you leave a cell which you have already visited and you are continuing your discovery process, you mark it as 1. So now here it was 0, but then you are going down, so you mark it as 1. So here also it was 0, but you marked it as 1. This also 1. So when you enter a particular cell, it has to be a 0. You cannot enter a cell which has already a 1 in it, which means that it has been visited. So you cannot repeat that cell. So this will make sure that you are not stuck in a loop, and then you can continue in newer directions and ultimately find your word. So this is the entire solution. And now next we will look at how we can convert this into a code. So we'll have the code and we'll walk through it, and again repeat that process there, which we saw in this explanation. So let's look at the code next. So let's look at the code now. So I have coded this in Java, but if you have followed the discussion along, and if you look at this walkthrough which we are going to do, then you should be able to translate this code easily into any language of your choice. So exist is the method which we are supposed to code. It has two inputs. One is the board, from where we have to find the given word. So our solution starts with some basic setup for the code to work. So important point is here is the visited array. So this array is the one which we discussed, that it will be used to prevent the search or the discovery process to go into loop. So in order to make sure that the search process doesn't go into loop, we have this visited array. It is a 2D array, and the size is the same as the size of the board. Now we have this iteration of 2D array, which is the board array. We are going, so now this is for example, if this is the grid, we said that in order to start solving the problem, we have to iterate this grid from left to right direction, and if we end the particular row, we'll start at the next row again in the left to right direction. So this is the part where we do the iteration. And now for every character in this grid for which we start the discovery process, we mark that particular location in the visited array as -1, which will indicate that this particular cell has been visited, and you don't need to enter into this location again. And now after that we start our discover process. So we'll look at the details of this method in some time, and then if the discover method returns true, which means that from that particular location, which is like this I and j, so whatever character was present at this location ij in the grid, from there, if we did a search, if we found that we could find the word, then we return a true value, and then we set this exists boolean value as true, and then break out of this loop, because once we have found out that there was a word which could be located from this particular character in the grid, there is no need to search it further, because we are only interested in know whether interested in knowing whether this particular word can be found once or not. So even if it can be found more than once, we are not interested in that answer. Hence, if it is true, you break out, and then you break out of the first loop. Then here you check whether you need to continue further. So if it came here after setting exist flag, we simply break out from the first outer for loop also, and then this is the place where we'll return the value true. If this discover process did not return a true value for a particular location ij, then we are supposed to look at other locations, other cells in the grid, and that is where this part of the loop will come into picture, wherein once if a particular location, if a particular cell which you have marked -1 and then you are coming back to that location, now you mark it as 0 because now it is unvisited, and you might have to visit this location again through some other cell. So you have to mark this as 0 when you are done searching a particular location. So that is the reason we unmark the visited array, you can say, by setting it back to 0, because initially when we initialize it, all values are 0. So you return it back to the same state, so that you can, if there is a need, this location can be visited again, and it can lead to possible search of that word. uh, After that you simply continue, and then you keep uh, uh, keep initiating your discover process for different cells in the grid by changing the values of I and j. And as soon as you find that you have found a word, you reach this place and you return a value. Otherwise you return a false, which is the default value. So now we'll look at the discover method. The discover method has 6 important parameters which are being passed in order to discover whether a word can be found out in the grid. So I, j is nothing but the location of the cell where you are at currently. So if you are here, I and j will be corresponding to this. If you are here, it will be corresponding to this, and so on. Char location is the location within the word which you are trying to find. If you are trying to find whether if you have found out already that f is at a particular location, but now you are looking for the character d, so your char location will be 2, uh, and then so on, depending on which location you are at. And then word is the entire word which you are looking for. In this example it will be fde. And visited is the array which is 2D array of the same size as the board or the grid which we have, to track that we don't uh, get stuck in a loop. And then this board is the original grid of characters which we have. The first thing which we do is that we check whether the character at location I j is not equal to the character at this particular char location. So if it's not, then we return false, so that we can continue our search in the remaining directions. And then if the character matches, uh, then this is the entire piece of code which we execute. uh, the first thing which we check is that now we know that a match is there, so we check if this was the last character to be matched. So if this was indeed the last character to be matched, we return true, because we know that we don't have to do any further processing, and we can safely return it till we reach the exist method, which will finally return the value of true. If this is not the last character, and if there are more characters to be matched, then as we discussed, we are following a direction right, down, left, and up. So first we do right direction, and then uh, depending on whether we can reach this location, we'll go inside it or we'll not go inside it. And that particular check is on this line, where we check that j plus 1 means that we are going to shift a column to the right. And then we check whether we, even after shifting our column to the right, whether we'll remain in the boundary of the grid. And then also we check one more thing, is that the location we are trying to go, is it unvisited or not. So if it is 0, it is unvisited. If it is -1, we cannot go inside it. So we can go inside it only if it is equal to 0. So same thing has to be followed for every other direction. So for down, you increment the row and do a check. For left, you decrement your column and you do a check. For upwards direction, you reduce your row size and you do this check. For right direction, for example, if this condition matches, then what we do is we set this particular location, the right location, the cell where we are trying to go, that particular cell we mark at we mark as -1, and then we continue our discovery process from that point onwards, which means that your rightmost location, I mean the right cell, the cell next to this particular cell, current cell, which is right to it. For example, if we are here, now if we want to check our discovery process for this cell, so we'll call the discovery process with the parameters of this cell. So the ij will be corresponding to this particular cell, and then when we reach this method again, we'll continue our discovery. Now if this discover method returns true, which means that when we went into this direction and like every character of the word matched, if we get a true value, we'll return directly from here and we'll not look at all the other directions, because we know that we have found out the word. If we have not, if we have not found out a word, which means that this statement will not execute, we'll go on to searching other directions. So we will look at down and then follow the same logic, that we will call discovery process. If it returns true, we return true, otherwise we uncheck it. We have discussed the logic of why we want to set it back to 0, because this location is something which we are backtracking. So now we have looked at this location, but it didn't, we were not able to find out the word through this location, so we mark it as 0. And because it is possible that we will reach this location through some other cell, and at that time we will want this value to be 0. Same. So basically, if you understand what's going on in a particular block for a direction, in this case right, then the same logic will apply for all the other directions. So down, left, and up, all of them follow the same logic. It's just that your coordinates and your checking logic will change, but all the other things remain same. So this is the entire code, and if this method along with exist is run, it will be able to find out whether you can find out the word in this grid or not. Now coming to complexities. So if I look at space complexity, it will be so visited array we are using, which is of size m into n. So that is one component, and then the other one is like the depth of discovery method. So the depth of the discovery method will be, the max depth of it will be equal to length of the word which we are trying to find. So if I say that length of the word is k, in this case it being 3, your space complexity will be omn plus k. And as far as time complexity is concerned, if you look carefully, we have m rows, sorry, m columns, maybe you can say, and n rows. So we have total m into n characters in the grid, and for each character in the exists method, we saw that we iterate each character and then start our discovery process. And so for each character we start our discovery process, and that discovery process is like, for now we have k as the length of the word which we want to find out, and for each character in that word which we want to find out, we have 4 possible directions where we can go. For example, this is that grid cell in the grid, then we can go either here, 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 and we cannot go back. But then there are actually 3 directions where you can go, but for the sake of calculating a complexity and coming up with a number, and for the uniformity sake, we'll say that you can go to 4 places. So maximum number of characters which are there in the word is k, and for each character we have four directions to look for. So we have four to the power k, right? Because we are going like 4 into 4 into 4 till the number of characters in the word. So our overall complexity will be m into n into 4 is to k. So just to put it clearly, it will be m into n into 4 to the power k. So with this, we come to the end of the explanation of this problem, and I hope that this entire discussion was useful to you. And like, if you enjoyed this discussion and if it was useful for you, please like this video and subscribe to our channel, so that you can be informed of newer videos which will keep coming up. And thank you so much for spending your time with us.